Hello and welcome to Beginnerology. I am delighted to introduce you to my friend, Professor of Physics, Dr. Satyaki Bhattacharya, who works in Saha Institute of Nuclear Physics, Kolkata, West Bengal. He is also involved in the Large Hadron Collider experiment at CERN, the European Organization of Nuclear Research, located at Geneva, Switzerland, and looks into the behavior of the subatomic particle. Outside his research, Satyaki is also interested in high school science experiments. I am delighted to invite him in Beginnerology.
Hello, today I am very happy to introduce the concept of Boolean logic gates, or just logic gates as they are usually called. The name is after George Boole, the famous mathematician who first introduced the mathematical idea of these logical structures. These gates are at the core of every modern day computer. Our modern day computers, inside their central processing unit, have millions of those logic gates implemented inside the CPU with electronic elements like transistors. But today we will not talk about transistors. We will show the idea of two very basic logic gates, namely the AND gate and the OR gate, with simple electrical circuits using bulbs and switches. So to start, let's look at this very simple circuit. It has a battery. There is a bulb here which I have underlined in red. I have called it Q, and between the battery and the bulb there are two switches, A and B. That's all that's there in this circuit. Now I will call A as input, B as input, and Q as output. The input can be only in two states, on and off. The on state I will label with number 1, and the off state let's label with number 0. So on is 1, off is 0. Right now in this picture, both A and B are in off state, which means the state of the input is A equals 0, B equals 0. The state of the output, which is an LED, are also two states. Either the LED is on and glowing, that will be 1, or it is off and not glowing, that will be 0. Now we will ask ourselves, what are the combinations of input that are possible? We are ready to look at this logic table. This is input A, this is input B, this is the state when both are on. The question we ask is, when the input is in state on, then what will be the output? Let's look at the circuit. When this is connected, B is also connected, then the circuit is complete, current flows and the light glows. That means the output state is on. What about when A is 0, B is on? That means this switch is open, that switch is closed. Circuit is broken, light not glowing, so Q, or the output, is 0. Similarly, if A is on, B is off, light is off. If both are off, obviously light is off. So such a table is called a truth table in Boolean algebra, and this particular truth table is known as AND. The reason is obvious, because for the output to be on, both A and B needs to be on. The symbol with which such a truth table is represented is this little picture in red. So it takes the D from AND. It has two input lines, A and B, and one output line, Q. And this table tells what all possible values A, B and Q can take. Let's look at another one. Let's look at this circuit. It again has one LED, the output Q, and two switches A and B connected to the battery, but now in parallel. Let's see what change that makes. Let's look at this table of OR. If A is on and B is on, then output Q is also on. What if B is on but A is off? So B is on, current will flow, so output will be on. Similarly, if A is on and B is off, current will still flow through A and Q, the output, will be on. Only if A and B both are open or 0, 0, which is what is drawn here, then current cannot flow and the output Q is off. So in this case, clearly either A or B being on is sufficient for the output Q to be on, which is the truth table of OR. In all these three cases, Q is on. Only when both are 0, 0, Q is 0 or off. So that gives us the truth table of an OR gate.
So you have seen what Satoki has shown, the AND gate and OR gate. We will try to add more gates as time comes. Basically, the binary system of computer language is run by these type of gates. Thanks for watching. We are sure to get more such guest lectures and guest lecturer in our Beginner Lab. If you got some new idea, you can just send a message.